Most skeletal muscle is attached to bone on its ends by way of what we call tendons. And as the muscles contract, they exert force on the bones, which help to support and move our body along with its appendages. In most cases, one end of the muscle is fixed in its position, while the other end moves during contraction. The origin is the attachment site that doesn't move during contraction, while the insertion is the attachment site that does move when the muscle contracts. The insertion is usually distal or further away, while the origin is proximal or closer to the body relative to the insertion. For example, one could say that the wrist is distal to the elbow. Conversely, you could say the elbow is proximal to the wrist. Muscular contraction produces an action or a movement of the appendage. We will use examples to describe how origin and insertion affect the action of a skeletal muscle. Muscle contraction results in different types of movement. The particular movement is a direct result of the muscle attachment. Most of these movements are realized when we run, as you see on the screen. Each of these actions can be described in one of two ways. The first describes action in terms of the bone to which the muscle is attached, or the appendage that is moved. For example, the biceps brachii performs flexion of the forearm, as the forearm is moved. The second way to describe a muscle's action is based on the joint or the articulation. For example, that same muscle, the biceps brachii, performs flexion at the elbow, in which the elbow is the joint. The human body has over 500 muscles responsible for all types of movement. Each of these muscles has a name. For example, again, the biceps brachii, and now the triceps brachii, responsible for both forearm flexion and forearm extension, respectively. When movement of a body part occurs, muscles work in groups rather than individually. Working together enhances a particular movement. Now, during that particular movement, individual muscles will play different roles depending on their origin and insertion. And these different roles can be described as agonists or prime movers, antagonists or synergists. Let's take a look at forearm flexion and identify the roles of the different muscles involved. The biceps brachii is the agonist in forearm flexion. An agonist, or as I said before, a prime mover, is the muscle that is primarily responsible for the movement described, forearm flexion. The action makes sense when you consider the muscle's points of attachment. The biceps brachii originates on the front of the scapula of the shoulder and inserts on the front of the radius in the forearm. Now, due to these attachments, contraction and muscle shortening of the biceps flexes the forearm. Now, the triceps is the antagonist, and its action opposes that of the agonist. The triceps brachii originates on the back of the scapula and humerus and inserts on the back of the ulna and the forearm. Due to these attachments, the triceps is stretched during forearm flexing. Stretching the muscle causes the triceps muscle to contract and thus slow flexion. Now, it's important to note that the antagonist contraction is minor in comparison with the agonist contraction, and therefore it doesn't prevent the action of the agonist. Rather, antagonist contraction controls the movement by slowing it down and making it smooth. Agonists and antagonists are always functional opposites. Additionally, these muscles switch roles with opposite movements. Let's take a look at an example. The triceps brachii becomes the agonist, while the biceps brachii is the antagonist when we extend our forearm. A synergist is a muscle that enhances the action of the agonist. For example, the brachialis is a synergist of the biceps brachii during forearm flexion. The brachialis originates on the humerus and it inserts on the front of the ulna. Now, as these attachments of the brachialis are similar in nature to those of the biceps brachii, so is its action. Oftentimes, synergist muscles are needed to get a particular action started. In summary, skeletal muscles are attached